In question number 19, a charged particle having a specific charge q by m is equal to 2 in SI unit is projected at time t equal to 0 from origin with velocity v vector is equal to 5 j cap meter per second inside a uniform magnetic field B vector. A uniform electric field E vector also exists in the space. Column 2 contains different parameters of charged particles at times corresponding to column 1. Match values of time t given in column 1 with appropriate options in column 2. So first of all, let's analyze the situation. Suppose this is my y-axis and this is my x-axis, and it is given that the magnetic field is 3i cap plus 4j cap. So the direction of magnetic field is somewhere here, and it makes an angle of 53 degree with x-axis. The magnitude of magnetic field is 5, and the electric field is acting just opposite to magnetic field in this direction, and the magnitude of electric field is 1. So this angle is 53 degree. Now a charged particle having a velocity 5 j cap, that is the charged particle is projected in this direction, so its component in this direction, that is v parallel, comes out to be 4 meter per second, and the component in this direction, that is perpendicular to magnetic field, comes out to be 3 meter per second. So in this case, the path of the charged particle will be helical in nature, and if I calculate r, that r would be equal to m into v perpendicular divided by qb. So if I substitute the value of all these variables, then v perpendicular is 3, q by m is 2, and the value of b is 5. So this comes out to be 3 by 10 into meter. Now the maximum z coordinate that may be possible is 2r when the time period is t by 2. So this 2r means this is equal to 3 by 5 meter. So if I calculate the time period, that is t is equal to 2 pi m by qb. So on solving, it comes out to be pi by 5 second. So let's check the times. At t equal to 0, the charged particle is at this position at the origin. So the correct matching will be z coordinate is 0. So q is the correct matching. The acceleration at that instant can be found out. So we can say that f is equal to q into E vector. E vector is given, that is minus 3 by 5 I cap minus 4 by 5 j cap plus q, which I have taken common, into v cross b. So the velocity vector is given by 5 into j cap cross magnetic field vector is given by 3 I cap plus 4 j cap. So this is equal to mass into acceleration. So the acceleration vector can be found out from here, that is equal to q by m into minus 3 by 5 I cap minus 4 by 5 j cap, and j cross j is 0, so it comes out to be minus 15 k cap. The value of q by m is 2, so if I substitute the data and solve, then we will find that the given acceleration is at t equal to 0. So the correct matching will be r, and the speed of charged particle at this moment is 5 meter per second, and the velocity vector is parallel to xy plane. So the correct matching will be qr and t. Now if I find out at what instant the speed of charged particle is 3 meter per second. So it means that the speed of charged particle would be 3 meter per second only when the component of velocity which is parallel to magnetic field must cease. So in that situation, I have to find out at what time it will occur. So final velocity along direction of magnetic field is 0. Initial velocity is 4 minus retardation in that direction is given by the electric field. So that is given by q into E, that is 1 by m into t. So if I substitute the value of q by m as 2, then the value of t comes out to be 2 seconds. It means this component of velocity must cease at instant of 2 seconds. So at that moment, the speed of charged particle will be 3 meter per second. So at this t equal to 2 seconds, the time is not the multiple of t by 2. So we can say that in that situation, for the option D, t equal to 2 seconds, the correct matching will only be S. Now when the time period is capital T, that is t by 5, in that situation the z coordinate again becomes 0. so the correct matching will be Q, and the velocity vector is parallel to XY plane, so the correct matching will be Q and T. When the time period is T by 2, in that case, the particle has reached to the maximum Z coordinate, that is 2r. So the value of 2r is 3 by 5. So the correct matching will be P, and the velocity is parallel to XY plane at that moment also. So the correct matching is also T. So in question number 19, the correct matching for entry A is QRT, for entry B it is PT, for entry C it is QT, and for entry D it is S. Let's move to question number 20. In question number 20, column 1 contains different rigid body of mass m, and column 2 contains moment of inertia about x is mentioned in column 2. So let's check the entry A of column 1. Right angle uniform triangular plate. So this is a right angle uniform triangular plate whose this edge length is A and this edge length is also A. Now we know that suppose it is a triangle and the perpendicular length of this triangle is h and its mass is m. Then the moment of inertia about this axis is given by mh square by 6. So if I use this result in this entry A, then moment of inertia about AB can be written as m perpendicular h is a square by 6. So this is the moment of inertia about AB, which is also equal to about AC. So we can directly see moment of inertia about AB is equal to moment of inertia about AC. So the moment of inertia about AB and AC are same. So we can write moment of inertia for AB is equal to AC, and that is equal to ma square by 6. Now if I have to calculate the moment of inertia about BC, then in order to calculate the moment of inertia about BC, I have to drop a perpendicular on this. The length of this perpendicular becomes equal to a by root 2. So if I calculate the moment of inertia about BC, then that can be written as m into h square. Now the perpendicular h is a by root 2, its square, divided by 6. So this comes out to be ma square by 12. So the moment of inertia about AB is ma square by 6, and the moment of inertia about BC is ma square by 12. So the correct matching will be T only for entry A. Similarly, if I see the entry D, then it is a uniform triangular plate. So in case of a uniform triangular plate, the moment of inertia about AB can be written as, this is the perpendicular separation, that is a root 3 by 2. So the moment of inertia about AB can be written as m into a into root 3 by 2 whole square divided by 6. So if I solve this, it comes out to be ma square into 3 divided by 4 into 6. So this can be cancelled out. So it comes out to be ma square divided by 8. Now in this case, if I calculate the moment of inertia about AC or the moment of inertia about BC, then all are equal. So the correct matching will be T only. Now if I check the entry B, then I have to calculate the moment of inertia about AB. So in order to calculate the moment of inertia about AB, I can consider it as a rod of mass m, and I have to calculate the moment of inertia about AB. So that can be calculated as m into L, ml square by 3. So m into a square by 3. And this is the moment of inertia same also about BC. Now I have to calculate what is the moment of inertia about AC. So in order to calculate about AC, I have to drop a perpendicular on this, and I have to drop a perpendicular on this. So this perpendicular length I have already calculated, that is a by root 2, and the mass of this triangle is m by 2. So I know the formula ma square by 12. So if I write about AC, then moment of inertia about AC can be written as 2 times ma square by 12. So m is m by 2 a square by 12. So it comes out to be m into a square by 12. So the correct matching will be P, Q and S. Now if I check the entry C, then the moment of inertia about AB can be easily calculated. I have to consider again it as a rod, and the length of this rod is A, so the moment of inertia about AB can be written as ml square by 3, so m into a square by 3. But now I have to calculate what is the moment of inertia about AC. So in order to calculate the moment of inertia about AC, I have to drop a perpendicular on this. Let its length is h. The area of this rectangle is 2a square, so the area of the half triangle is a square, and that a square must be equal to half into base. The length of this base would be root 5a into height. So from here the value of h comes out to be 2a by root 5. Now if I have to calculate the moment of inertia about AC, so that can be written as 2 times mh square by 6. So the value of m is m by 2. The value of h is 2a by root 5 whole square by 6. So on further solving, it comes out to be 2 by 15 of ma square. So the correct matching will be Q and S. So for question number 20, the correct matching for entry A is T, for entry B it is PQS, for entry C it is QS, and for entry D it is T. By this, I wish you all the best for your preparation. Have a good luck. Thank you.